Okay, so I'm going to repeat the NAT, which is the Network Address Translator. So as we discussed, the VPC, subnet, route tables, internet gateway, and how to make a subnet from private to public. So let's discuss a scenario here. I have one VPC, and in this VPC, the CIDR block for the VPC is 10.0.0.0/16, and there are two subnets.
You're not sharing.
Okay, can you see now?
Yep.
Is my screen visible now?
Yes.
Okay, right. So we have one VPC, and the range of the private IP address that we call CIDR block is 10.0.0.0/16. So it is having almost 65,356 IP address. Now we have two subnets inside this, and these two subnets are subnet 1 in availability zone 1, subnet 2 in AZ2. Okay, then the CIDR block of the first subnet would be 10.0.5.0/24, and the CIDR block for second subnet 10.0.5.0/24. So how many of you agrees that this subnet could be the possible CIDR block for this particular VPC? Can the two subnets have the same CIDR block inside one VPC? No, exactly. So as per the rule, the CIDR block of the subnet should be the subset of CIDR block of VPC, and the CIDR block of subnet should not overlap with any other subnet inside the same VPC. So here the subnet to CIDR block 10.0.5.0/24 is not a acceptable CIDR block. So instead of 5, we can go ahead with any other number: 0, 1, 2, 4, 15, 10. Now, since we have two subnets, these two subnets will be internally connected to the main route table, right? And next, I will create one more route table that will be the custom route table, fine. And this custom route table will have one internet gateway attached to it. Then I will attach this particular custom route table with subnet 2. So when I do so, the subnet 2 will become public and subnet 1 will remain private. Fine. Now let's launch one instance in public subnet and one instance in private subnet. And I have my user here who wants to communicate to the EC2 instances which I have launched in these two subnets. So let's take the first scenario where my user trying to connect to EC2 Linux instance which is there in the public subnet. So the traffic will flow to internet gateway, from internet gateway to custom route table, and custom route table will divert the traffic to EC2 Linux instance in public subnet. This is very much possible. Then the EC2 instance will reply back through custom route table and internet gateway to the user. So this communication happens successfully. Now, in the second scenario, my user trying to communicate to the second EC2 instance, which is in private subnet. So the traffic will flow from user to internet gateway, then to custom route table, then from custom route table to private EC2 instance. But this, okay. So how many of you agree that this traffic can successfully flow? How many of you agree that this could be possible?
It's not possible.
Why?
Maybe because the internet gateway and the custom route tables are not attached to the private subnet.
Internet gateway is not attached to the private subnet. Indirectly, you can say that, but how can internet gateway be attached to one subnet? Internet gateway is attached to the custom route table, and custom route table is not associated with the private subnet, right?
Yeah.
So the traffic coming from internet gateway to custom route table through custom route table, it will never go to private. It will never go to the private subnet because that is nowhere in its route. So private subnet is connected only to the main route table, and in main route table it do not have any internet gateway route, right? So this intended communication will not take place. Agree? Everyone agree? Anybody having doubt? No? Okay. Now let's take another scenario here. My EC2 instance in private subnet wants to download some updates. So if it wants to download any updates, it must be connected to the internet, right? So it should be able to communicate to the internet so that it can download the packages. Now if so, then how my EC2 instance will try to communicate to the internet? It will talk to its route table. It will find the routes in its main route table, and then it will try to communicate to the internet gateway. But since its main route table do not have any entry for the internet gateway route, this communication will not take place. So now in this scenario, the challenge is that my user do not want my user wants to communicate to EC2 instance in the private, but they cannot communicate to this, and even the instance is not able to communicate to the internet. So if I want to solve the first case, that let my user communicate to my EC2 instance, then I will bring my EC2 instance in the public subnet. And if I do so, my user can easily communicate to the EC2 instance, but I don't want to do so. I don't want to do so.
Because is it like cannot attach custom route table to the private subnet?
Yes, because if we attach the custom route table to the private subnet, it will not be there, it will not be a private subnet anymore. It will become public, just like the subnet 2 become public.
What is this custom route table actually? Exactly.
Okay, so whenever we create any VPC, the main route table gets created by default, and the only rule that main route table have is the internal communication. Okay, so any communication that is
Mm-hmm.
originating from the CIDR range of 10.0.0.0/16 will able to communicate internally, or you can say locally. So any communication let's, for example, a communication is originating from 10.0.1.0 and it wants to communicate to 10.0.5.0, then they can easily communicate within the same VPC. But now I want to add one more route that any person through internet can communicate to my resources in this VPC. So if I want to add this route, then there are two options. I can directly add the route in the main route table, but if I add the route in the main route table, the same route will be propagated to both the subnets, and that route will make both the subnet public. But I want to make only the subnet 2 as public. So in that case, I will create another route table, and I will attach the route table only to the subnet 2, so that only subnet 2 will become public and subnet 1 will remain private. Why we do so? Let's say that I have a two-tier application where I'm launching my website in public subnet so that public can access my website, and I have my database server. I don't want anybody to access my database server from publicly. I will keep it in the private instance, private subnet. So for these kind of practical scenarios, we used to go for the public and private subnets, so that all the resources in the private subnets cannot be accessed directly through internet. Clear?
Yes, Akash.
Okay. So here the scenario is that I do not want my users to communicate to my instance, but I want to allow my instance to communicate to the internet. Why? Because I want my instance to get updated and to download the updates at regular interval. Fine. So if I want to allow my public user to communicate to my EC2 instance and the EC2 instance to let them communicate to internet gateway, then I can simply bring my EC2 instance in public subnet. But here my requirement is not both. My requirement is that my EC2 instance can only communicate to internet, not the any users. So if I want to prevent the users to communicate to my server, and I want to allow my server to communicate to the internet, the main purpose of getting the downloading the packages for updates, then I need to use NAT, which is called Network Address Translator. So let me show you how it works. Fine. Any doubt till this point? Anybody? No? Okay, let me move ahead now. Fine. So my EC2 instance in the private will communicate to the EC2 instance in the public, and then my public instance will communicate to the internet. It will get the package down, and then it will move the packages to the private instance. So now this is possible. The communication is taking place. My EC2 instance in the private subnet is able to download the packages. How? Through EC2 instance in the public. So when such things happen, then we call the EC2 instance in the public as NAT instance. How we call it NAT? Because it is working as a bridge by translating the network address. So let me tell you how it translates the address. EC2 Linux Web, the private instance, is having its private IP address. It do not have the public IP address. And EC2 Linux NAT in the public instance, public subnet, is having its private IP address as well as public IP address. So when private EC2 instance sends the communication to public EC2 instance, the public EC2 instance know the private IP address of the first one, and Okay, yeah. So the instance in the private subnet sends the communication to public instance with its private IP address, and the private IP address is being translated to public IP address of EC2 instance in the public public subnet, and then the public subnet is instance communicates to the internet using its own public IP address. Once the internet sends the response back to the EC2 instance Linux NAT, then EC2 instance Linux NAT again translates back from the public IP address to the private IP address of EC2 Linux web, and it passes the packages to the private EC2 instance. So this is how the NAT work conceptually. Clear? Any doubt?
So you say NAT stands for Network Address Translator?
NAT stands for Network Address Translator, and let me give you an example. So this is having its public IP. Okay, this is okay. Fine. So the EC2 instance in the this public subnet is having the IP address 10.0.2.1. So this is the private IP address, and public IP address of this is, let's say, 43.23.46.1. Okay, and the private IP address of this instance, which is in the private, is 10.0.4.2. Okay, and this is public and this is private. Okay, so what happened? This instance it EC2 1, and let me rename it to EC2. So when EC2 1 instance sends a communication to EC2 2 instance, then EC2 2 translates the 10.0.4.2 into 43.23.46.1, and then it sends the traffic using this public IP address to Internet Gateway. When Internet Gateway responds back to 42.23.46.1, then EC2 instance 2 translates this public IP address of its own into the private IP address of EC2 1, so that the traffic sent back to EC2 1. So this is how it happens. Let me know if you have any doubt, if you want to discuss it.
That is clear. Let's go back to the previous
Right?
the previous explanation. You said in order to avoid making the EC2 instance, the private EC2 instance from connecting like maybe public, you need to create another main route table and then attach it to, say, the EC2 public instance to avoid that the connection shouldn't be public. I need to be clear on that.
Okay. So these are the two subnets, right? Subnet
Yeah.
1 and subnet 2. These two subnets will be connected to the main route table. Fine.
Mm-hmm.
And the main route table is having only one route. The route says 10.0.0.0/16, which is the CIDR block of VPC, can communicate internally, locally. So this is the only route that main route table have. Fine.
Okay.
Okay. Now let's say that I want to make subnet 2 public, and I don't want to create a custom root table. Fine. So I will add one entry in the main root table. I will add one entry in the main root table saying that please allow the traffic coming from internet through internet gateway to this. So if I add that root in the main root table, then both the subnets will become public because both are connected to them by default. And we cannot deassociate any subnet from the main root table because main root table is the root table which is internally connected to all the subnets.
Correct.
Right? So in this case, if I add the internet gateway root in the main root table, both my subnets will become public. But I
Yeah, both
want
instances will become public, right?
sorry.
Yeah, you said if you add the internet gateway to the main root table, connection will be made public for both instances.
Yes. So
So
if
to
I
avoid that, what do you do? That's what I'm trying to be clear on.
yeah. So this up to this you are clear, right?
Yes.
Yes. So what we can do, we will make one more custom root. We will create one more root table. We'll create one more root table and we call it custom root table because we are creating additional root table. And
Okay.
when we create the custom root table, then whatever root is there, when I create the custom root table, whatever root is there in the main root table, it will get copied to the custom root table. So in the custom root
Okay.
table, also I will have one a root, and that root will say that any traffic which is originating from the VPC can communicate within the VPC locally. Fine. Now I will create one internet gateway and I will add the internet gateway in this custom root table, not in the main root table. Fine.
Okay.
And then I will add the custom root table to the subnet which I want to make public.
Okay.
So I connected the custom root table to the subnet 2, and then subnet 2 will become public and subnet 1 will remain private because subnet 1 is not connected to the custom root table. Subnet 1 is connected only to the main root table, and subnet 2
Correct.
got connected to the custom root table which is having internet gateway. Clear?
Yeah.
So this is the way how we do. Let me give you one practical example. Okay, so no, we can make any. Okay, that was an explanation. Fine. So Congo and Hasni, I am going to explain you it practically. Okay, so I will start from the very basic that I will create the VPC to show you. I mean, whatever diagram I have explained you in the slide, the flow I'm going to create in AWS now. I will quickly do this and then I will let any one of you to take the screen and do it. So anyone having the doubt will be given the preference. Okay. So I am in my this AWS console and let me go to the VPC. So I am in VPC and I will choose a region which is untouched. So I will not be having anything in that region. Let me choose one such region. Okay, so I will go ahead with the Ireland. So I changed my region to Ireland. All right. Uh, then I will not get started with the wizard. You can see start VPC wizard. So I will not be doing this because this will create everything by default for me. So I will be starting with individual components. Okay. So the very first thing that we will do is that we will create one VPC, right? So anybody stop me whenever you have any doubt. Fine. I have one VPC here, and we know that this is the default VPC because we have not created any VPC in this particular region. So let me rename it to default so that I do not get misguided. Fine. Now let me create one VPC, and the name of the VPC are demo 10. So demo 10 is the name of the VPC. And the CIDR block I will use 10.0.0.0/16. So the very simple, and let me create this. So the very first step I did is I created the VPC. Fine. Now if I go to the root tables, I can see this root table is there. This one is for the default root table. This is the default root table because this is for the default VPC. And here you can see this is for the demo VPC, the one which we created. So demo underscore 10 underscore root underscore table. So this is the root table which got created along with my VPC. Fine. If I go to the roots here, then I will see only one root. So this is the by default root which gets created. You cannot delete it, you cannot edit this. So this is the by default root, and it says that any traffic or any request that is originating from within this range 10.0.0.0 can connect locally. Okay, this is the only root, and this root says that anything that is there in the VPC will be private. So for now my VPC is private. Now let me create two subnets inside this VPC. I already have three subnets, and these subnets are the defaults are the subnets of default VPC. So let me rename this so that I do not get confused. Default underscore 01, default underscore 02, default underscore 03. Okay. Now let me create two subnets. Demo underscore 10 underscore 01, or let me use this name subnet underscore 01. The VPC will be demo, and here I will give the CIDR range. So 10.0.0. Anybody want to help me with the CIDR range? It will become a practice for you. Let's try out. So message me the CIDR block which will come as the subset of this one. So anyone. Nobody trying? 10.0. How come this be the CIDR block of subnet? Congo, this is the CIDR block of VPC, and if we go ahead with this CIDR block range, then we will not be able to create the another one. This you seems to be right, but the /16 is not the valid option. So 10.0.0.0/24 Trilok and Chris, you are posting one particular IP address, and we should have the range of IP address for this subnet. So CIDR block. Would you like to try another one?
Hello, sir.
Yes.
Yes. Can you please explain why it is 24 and not 16?
Sorry.
Can you please explain why it is 24 and not 16?
Okay. So if you recall the previous session, if I use 16 here, it means it will cover all the IP address which has been defined for this VPC. So you can see for VPC we have defined 10.0.0.0/16. And if I use the same CIDR block range for the subnet, all the IP address will be occupied by only one subnet, and I will not be able to create the another subnet because no IP address will left for that. Now that's why we cannot use the 16 one because it will occupy everything. If I change this to 20, then it is acceptable. But why we do not go for 20, 21, 22, 19, 18? Because if we go with that, then we will have to calculate the exact IP address with the maximum and minimum value. But what if I go with 24? If I go with 24, I will be just needing to change the third block because 24 means first 24. 24 means first three block will be fixed. Only last block will vary. So if we go with the 24, I will just need to change this 0 to 1, 2, 3, 4, 5, 6, and rest of the things will remain same. So likewise, we can create 256 subnets with the same pattern. So I create this one. Let's say that I do not want to create with 1. I can go ahead with 1 or 11. So that is also possible. So let's take the one 10.0.11.0/24, and I created the first
You can
subnet.
also use /28, right?
Sorry.
Use /28.
Yes, we can use the /28 also, but that will reserve only 16 IP address. So generally, we do not go ahead with reserving the 16 IP address because it's very less for one subnet. So we generally prefer to go with the higher one. Okay, subnet one is done. Now let's create the subnet
So
2.
you created a subnet one under which availability zone?
Subnet one I have created
It looks like you did not specify the availability zone.
yeah, so it was not this one. But if you take that in which availability zone it is there, and it is in EU West 1A. So
Okay.
so it was like no preference. No preference means they will pick up by default anyone. There is no link. So it was 1A.
Okay.
This time we will select EU West 1B. And it is not mandatory.
Okay.
Yeah, and it is not mandatory that we select the availability zone every time in different availability zone for different subnet. Multiple subnet can be in the same availability zone.
Okay.
So subnet 2 is the other subnet which we will be creating, and the CIDR block for this one be 10 dot which is O dot. We used 11.0/24, so this they will not accept. So it says that already one CIDR block with this is existing and it is overlapping. So you just need to check.
So you can change 11 to 12.
Yeah, so you can change the third block. The 11 is already occupied. So what 11 is now out, You can choose any one from starting from 0 to 255 except 11. So I can go ahead with 0 also. I can go ahead with 255 also. They will accept it. They will accept any value from 0 to 255, but it will not accept 11 because it is already in use.
Okay.
So let's go ahead with the simple one. 11 we have already used, so let's use 10 for this and just create it. So now, as per the diagram, we are done with the VPC, we are done with the subnets.
Subnet.
Fine. Now these subnet, if you see here, this subnet is by default attached to the demo 10 root table, which is the main root table. Fine. Can you see?
Okay.
And if you select the first subnet, this is also by default connected to the main root table, and it is having only one root. So by default, both the subnets are private. Clear now? Okay. So if I want to make any of these subnets public, then I will have to add the internet gateway to that. So let me create one internet gateway here. I go ahead and create one internet gateway and I give the name 10 demo underscore 10. Now I have this internet gateway available to me. So I will attach this to VPC. Unless you attach the internet gateway to VPC, you will not be able to use the internet gateway in creating the routes. So attach this to VPC 10.1. Now you can start using this. So the first scenario that we were discussing, this is the demo route table. So let me rename it. Uh, Let me rename it to main route table. Okay. This is the main route table which came by default along with the VPC, and it is having only one route. So I can edit this and I
So
can,
quick question.
yeah.
So the root table is created by default when you create the VPC.
So whenever we create any VPC, one
Yeah.
one route table gets created along with it, which is called main route table. So
Okay. All
this
right.
is the main route table which got created by default along with the VPC.
Okay. Cool.
And now since we want to make our subnet public, I will have to add the routes to the route table. So this is the main route table, and if I add the route here for the internet gateway, so if I save this, it means I have added the route, this route, which is making it public. So I have added this rule in which main route table, right? And main route table is connected to both the subnets. So by doing this, both the subnet became public. Clear? But I don't want to make both the subnets public. I want to make only one subnet public. That is subnet 2. And in that case, I cannot change the main route table. So let's recall the changes that we did in the main route table. I will remove this in the main route table. So my main route table is having only private route now, and both the subnets are connected to the main route table. In this case, I can now, since I want to make the subnet 2 as public and subnet 1 should remain private, I will create one more route table which we call custom route table, and we'll add the route in that custom route table, and then we'll connect that route table to the subnet 2. So let's name it custom route table, and this custom route table is having the by default root of main route table. Now I will add it and I will add the rule here 10.o.1 4.4/2, and here I will select the Ethernet gateway. I will save it. So when I do this, my custom route table is there, but this custom route table is not attached to any subnet. So my custom route table having internet access is not attached to any subnet. Or now, if I attach subnet 2 with this custom route table, in that case, only subnet 2 will be associated and only subnet 2 will become public, not the subnet 1. Clear now?
Yeah.
Anybody not clear? This is very important. Please let me know if you are not clear. I will repeat it, no problem.
Vikas, if you could repeat it once again.
Okay, from which point?
In the custom route table, how we added, I mean the IP address which you gave while creating the custom route table.
Okay, so IP address is not understood, like VPC and subnet.
No, while creating the custom route table, you gave.
Okay. So when we create a custom route table, we click on create route table, okay, and
Yeah.
we select only VPC. So this is the VPC, and I will name it custom route. Fine. So
So
VPC,
in the VPC, why are we selecting the demo 10? We are using the.
we are using this one, demo 10 VPC. We have
Okay.
selected the
Okay.
demo 10 VPC, and custom route table or subnets whatever we are creating in this particular, not touching the default one.
Okay.
So when we create the custom route table, only two information is being asked. For which VPC you want to create it and what should be the name of this. After giving these two information, I click on create the custom route table. Now, once I create the custom route table, it will become exact replica of the main route table. So if you see the routes, it is having the routes which is available in the main route table. Okay. So whenever you create any custom route table, it will become exact replica of the main route table. Now you can add something additionally in this custom route table which will not be reflecting in the main route table, so that these two are isolated.
Okay.
So I have created the custom route table, and my intention of creating this is that I want to make the subnet associated with this public. So to make any subnet which will be associated with this custom route table public, I will have to add a route, and that will be the public route. So let me add the route here. So once you create the custom route table, go to the routes and edit it, and then you can add the another route. So click on add another route, and here you will type 0, I mean o.o.o.o/o. It means that any traffic, I mean
Connection.
any IP address can initiate the communication. So this is open IP address, which means for public, means any internet, any request that is coming from internet can be generating from any IP address. We are not restricting this to any IP address because on internet we do not have the restriction of the IP addresses. So if I'm expecting the traffic to come from internet, it can be from any IP address. So that's why we have given this open range of IP address, which means that it can be any IP address.
Okay, can I ask a question?
Yeah, sure.
Yeah, can you attach multiple custom route table to a single subnet?
Yes.
Say
No.
like you have just created this one. Can you still attach this custom route table to the subnet that you attach the custom route table one to?
One subnet.
Do you get the question?
Yes, I got the question, And the answer is that one subnet can be attached to only one root table at one point of time. But
Okay.
multiple subnet can have the same root table. So let's say that, I mean, right now we are having only two subnets, subnet 1 and subnet 2. Suppose that we have 5 subnets, subnet 1, 2, 3, 4, 5. And we have 3 root tables. One is main root table, which will be internally connected by default to everyone. Then we created 2 custom root tables, custom root table 1 and custom root table 2. So custom root table 1 and custom root table 2 cannot be connected to any of these subnets together. But multiple subnets, subnet 2, 3, 4, can have one root table connected to it.
Okay.
Here,
Uh,
let me show you. So this is the open IP. Hasni, now is it clear?
So
Yes,
technically,
sir.
you're saying that multiple subnet can be connected to one root table, right? Let's say one custom root table. But
And then, yes,
it,
multiple subnet can have one root table associated, but
but one root table cannot be connected to where one let's say multiple root table cannot be connected to a single subnet.
we have.
It's like we are connecting the subnets to the custom root table, right? If we want to make that subnet public.
So we have one main root table and one custom root table. In main root table, we have just the private root, and in the custom root table, we have private roots as well as public root. So if I want to make any subnet public, I will connect this to the root table which is having public root. So that is what we are doing. If I right now my intention or our intention is that subnet 2 should be public. So to make subnet 2 public, I will connect to some root table, which root table is having a public root. So this is the public root. So the custom 2 is having the public root, and if I attach this to any subnet, that subnet will become public. Okay. To answer your question,
Yes, sir.
to answer your
Hello?
question, yes.
Okay. Go ahead with him. I'll ask my question later.
So I was saying that subnet 2 is already connected to one of the root table, which is custom root table, this one, and we are in custom root 2. So if I go to this and I try to connect this particular root table to the same subnet, I do not have an option. See, I have only one subnet available here. Subnet 2 is not available. It means two different root tables cannot be connected to one particular subnet. Is it clear now? Yeah, any more questions?
Yes, sir.
Yeah.
Uh, I want to ask, must we always leave the custom route open in any situation?
I didn't get you, sorry.
Like must we always leave the custom route open in all situations?
So, whenever we want to add any root, we create a custom root table. We do not touch the main root table because touching the
Yeah,
main.
I understand that. My question is,
Mhm.
in all situations, must we always leave the custom route open, like 0.0.0.0.0/0, or are there some situations where we might be forced to probably make it dedicated?
So this 0.0.0.0 This is used only with
Yes. So,
gateway.
yes. My question is: are we supposed to use the 0.0.0/0 in all situations, or there are some situations where we might be forced to maybe make it dedicated?
Yeah, so there are different scenarios we will be discussing in later slides. To answer your question, this is not mandatory. This is used only when we are not sure who is going to use it. But when we are
Okay.
sure that the people who are going to use it will be originating from this range of IP address, then we give the range of IP address. But from, I mean, now we are not sure about the range of IP address or any specific IP address from which people will access it, because it will come from internet and it could be any IP address. So when we are not sure of the IP address, then we give it this one, open to all.
I can even give one particular IP address in this, is it?
You can
So
give
that
one
that
particular,
particular person can access this.
yes, so you can give this also. But
Okay.
you must be I mean, you must be sure about the IP address. And when you give the IP address here, they will not accept the IP address unless you give it in the block format. So let's say I'm giving it 132.95.12.34. It will not accept unless I give it in the block format. So if I use /32, it means only this IP address. /32 means all the 32 bits are reserved. It will not change. It means just one IP address, but the representation is in the block format. Can you see this? So adding this route with only this IP address, the person who is using this IP address, only they will able to connect through internet. Clear, Hasni?
So technically, it depends on business needs, right? So
Uh, okay. So let's say that I am having one database in this particular subnet, or some application in this particular subnet, and one of the business organization who is situated in some other geographical location wants to use this resource in this particular subnet through internet. So they will be coming and they will, I mean, their request will be coming through internet, right? So when they are posting their request through internet, but I know that the request will be generating from this particular corporate building, and this corporate building is having the IP range from this to this. So now I am clear that this is the IP range of this corporate office, and any request coming from that particular corporate office onto my cloud into this VPC will be within this particular range. So I will give the range here, and after giving the range here, there will be public access, but the public access will be only to the people who are originating their request within the specified IP range, not to all.
okay, it's understood.
Or let's say that, yeah, I got a question. Let me check the question. Must the subnet 1 and 2 always have the same CIDR block? No, it cannot be, because subnet 1 and subnet 2 cannot have the same CIDR block. That is what we were discussing, that subnet 1 and subnet 2 cannot have the same CIDR block, because then it will overlap. It will overlap means one IP address cannot be in the subnet 1 as well as in subnet 2. So we need to make sure that the CIDR
Hmm?
block is not.
At the class, at the class. Huh? At, oh,
Yeah, Hasni, are you clear now?
Yes, because I'm clear with it.
So you can see here I have specified only one IP address, and in this case,
Right. But that 32, how do you define that?
/32, see, whenever we have a CIDR block range definition, and uh, we want to define only one IP address. So we use this format /32. It means that all the 32 bits of this particular IP address is reserved. So even this is the block representation, but I am using
Okay.
this. I mean, wherever there is that, use the block representation. So this is just for the block representation, and I am having only one IP address for this. And if I use 31, it means 132.95.12.34 and 132.95.12.35. So these two IP addresses will come. But if I make it 32, it means only one IP address. But sometimes it happens that they will not accept the one IP address. If I use this, they will not accept this. It is saying that must be a valid CIDR block. So I will have to define this particular IP address in CIDR block format. So then use 32. So now it is one IP address, but the format is in CIDR block. Clear, Hasni? She got disconnected again. Okay, so any doubt? Shall we move ahead now? So I have two subnets now, subnet 1 and subnet 2, and we made subnet 2 public. We have seen that how to make the subnet 2 public. Fine. So guys, clear? I'm not getting any response. Okay, that's fine. So now one small change that we need to do here in the VPC, go to the action and edit DNS host name resolution. So this will make sure that we are getting the public DNS for the instances that we are launching in public subnet of this VPC. And then go to the subnets. This is the subnet which we make public, subnet 2, right? Go to the subnet action and then modify auto IP assigning settings. So when I enable this, it means it will allocate the public IP address for the instances which I am going to launch in this subnet. If I do not enable this, then I will not be getting the public IP address for the instances which I will be launching, and then I will end up with creating one elastic IP address attaching this to the instance. So let's enable this and save it. Okay. If you forget these two steps, then you will have to create one elastic IP address, attach this to your instance, and then only you can use it, even if you are launching the instance in public subnet. So we are done with this. Now let's go to the EC2 instance and create the instances. So guys, we are done with the VPC, root table, custom root table, internet gateway. And the subnets that we created, one is public and one is private. Now it's ready. So what we will do, we will create one EC2 instance in the public subnet, that is subnet 2. So I'm in EC2 console. I will go ahead and launch one EC2 instance, but we need to make sure that we are selecting the correct subnet. Okay, so I will go to the community AMI, and here I will search for NAT, and I will select the first one. Go to the configure instance setting, and here I will change the VPC. I will use the custom VPC that we created.
Can you start the process again, please?
Sorry?
Can you start the process of that NAT again, please? Can you start it all over?
Okay.
I missed it.
Okay. I just cancel it. I am starting it again. launch EC2 instance. In the launch EC2 instance, we will not select this Amazon AMI for the instance which we are going to launch in public. We will be selecting it from community AMI and we'll search NAT because I want the public instance to behave as the NAT. So for that we need one NAT instance. So I will search for the NAT instance here, and the very first option that we get, we'll use it. Second step, we are not going to do anything. Move on to the third step, and here I will change the network. Network means the VPC. So I will select the VPC that we created, demo 10. Inside this, I will be using the subnet 2 because this is the public subnet. Make sure that you are using the correct subnet. Fine. Then need not to select anything. Go with the default option. Nothing to do in the add storage. Nothing to do in the add this one. Okay. So now security group. In the security group, you need to add HTTP and HTTPS. Unless you make this change in the security group, you will not be your system will not be able to perform the NAT function. So HTTPS, yes. Now go ahead and change this to magnetic one. Need not to go for the general purpose SSD. Next. Next thing I will do is I will create one key pair because I do not have any key pair in this region. So I will create one key pair saying Ireland and will download the key pair. Okay, save it and launch the instance. So I will copy this file. Now it's here. By the time my instance is getting up and running, I will change the PM file to PPK so that I can connect, load it, and on desktop I search for Ireland. Here it is. Open this, change the parameter to SSH1 and save the private key. Using the same name, I will save this PPK file and will close this window. Now coming back to the instances, let's see the status. So my instance is still checking its health status, and we can see this is the public IP address we got assigned. If you are not getting this public IP address, there could be two reasons. One, that you have launched it in subnet 1, not in the subnet 2. So if you are launching this in private subnet, you will not be getting the public IP. Even if you have launched in correct subnet and you are not getting the public IP address, it means you will have to change the setting of the subnet. You will have to enable the auto assign IP address. So these are the two troubleshooting steps you can perform if you do not get the public IP address. And the solution for this is that once your instance is up and running and you do not get any public IP address, your subnet is correct, then go to the elastic IP address, generate one, and attach this to the instance. So let me name it NAT. Okay. So my instance is the NAT instance. Okay. By the time this is coming up, let's create one more instance. And this time we will use the simple Amazon Linux AMI. This will be the private instance which we will be launching in the private subnet. So from here select the correct VPC and we'll go ahead with the subnet 1 because subnet 1 is the private subnet we have configured. Click on review and launch, and then you need to change the security group here. So in the security group, add the rule made HTTP, then add HTTPS, then launch it with the same key pair. So we created two instances, one in private, one in public. So we'll rename this as private instance. Private instance. Done. Okay. So one is in EU West 1B and EU West 1.2. So these are the two availability zones we have, and okay, still taking time. Yeah, so now NAT instance is ready. We can connect to this. So let's connect to this instance. We are connecting to the NAT instance, which is available in public. So we should be able to connect successfully. There should not be any network issue. So let's try connecting to this. Create new session. Here I will use the public IP address, and in SSH I will go ahead and select the key pair Ireland PPK. Okay, and then open it. So successful connection. Use the username here, and now we can see that we are connected. So the public user can communicate to my instance, which is there in the public subnet. Fine, this one is tested. Let's test one more thing. Sudo -s, and I will type yum update -12. So you can see it got down. It started downloading the updates and the update packages. It means my instance is also able to communicate to the internet. So both way communication happening over the internet, but only for the public instance, which has been launched in the public subnet. Let's get this done. By the time, let's check the status of the another one. Okay, so it is still initializing. Okay, so if we look at this diagram, all the setups are done. We created VPC, we created subnets, main route table got created, then we created the custom route table, we added the internet gateway in the custom route table, then we associated this particular subnet to custom route table. After that it become public, and the subnet 1 will remain private. Then we launched two EC2 instances. Yum update -y. It was not yum install update -y. Then we launched two instances. One is for NAT, second one is for NoFlow. Now I got connected to this instance, and the first communication is happening successfully. So this is the command we type: yum update -y, not the yum install -y. Okay. So now, if we want this, particular instance to act as NAT, then we will have to enable one setting here, and that setting is select this instance, go to the action, and go to the networking and change the source destination check. So if you disable this, then now this instance will behave like NAT instance. Okay, fine. So which is my okay, let me go back to my main root table. So this main root table. Now here we need to add one more root for the public or for the private subnet so that they can communicate to the EC2 instance, NAT EC2 instance. So click on add it, add one more root, and here you select this NAT instance. Here you can select 10.0.0/60 and just save it. Okay, so we will need to make this 1 and we can make it 10. Cannot create a more specific route for this. If I go to custom route table and do 10.0.11.4/24 this one. Okay, fine. Okay. So in the second instance, we do not have the public IP address or public DNS. We have only private IP address. So we'll copy this. All right. So now we are on public instance. Now we want to connect to the private instance. We do not have the public IP address of the private instance. We only have the private IP address. So what we can do from this instance, we are already into the private instance. From this instance, using SSH, we can connect to the private instance. So for that, we will be using this command SSH -I, then the key .pem key, and then EC2 user @ private IP address. So this is the command we will be using. But since we do not have this key, so we will have to generate one key. And for that, we will use vi key, and we'll go to the PM of this, open this, copy everything from here. So copy the content of .pem file and then save this. Now what we need to do, we need to change the permission of key file of 600 and then use SSH -I key.
Can you let me see the name of the file that you created?
Sorry,
I just want to see the name of the file that you created.
name of the file.
Yeah, just list it. Let me see. Not the content.
So this is the content which begins.
Yeah, I just want to see the.
Can you see now?
Yeah, I'm saying the content. I just wanted to see the name, like, you know, ls to co ls -htr to see the name of the file that you just created.
Yeah. Can you see now?
Okay.
All right. So now let's SSH sh minus I e is to user at the rate 10.0.11.1. It is. Now you can see I got connected to the second instance. So now I'm into private instance. I got connected to the private instance. Let's clear this and change as the root user here. Now if I run the command yum update -y, it will not get updated because it is not able to connect to the internet. So now let's troubleshoot. So we have done all the setup except one. We have not added the root to the custom table. So we have this custom table and we just this. So my private instance is in subnet 1. And what is the CIDR range of? So 10.0.10.0 slash 24 here is NAT instance and save it. Cannot create a more specific route for this than CIDR with association and okay. We need to check why it is not letting us. Okay, it is not still able to connect. Fine. Let me troubleshoot this. I'm getting some issue in this. So setting up NAT instance in VPC. So here is the tutorial you can also find on internet. We have launched this, and unless traffic is minimal, then choose basis one, choose configure instance detail, choose public subnet in VPC. Okay, that is done. Then this is not the correct one. Okay, So just a small mistake I was doing here. Yeah, now it is done. Let's check. Yes, so you can see my private instance is now also able to download the package. So the purpose is that here you can see this private instance is not exposed to the public user. They cannot access it because this do not have any public IP address. So if you do not have public IP address, how can you communicate to any instance, right? So this is one. And once my EC2 instance is there, I set up my NAT instance here in the public. Then using the NAT instance, my EC2 instance is able to connect to the internet and get the package downloaded to it. So you can see this is the private IP address of my private instance. Here you can see this is same, and this private instance has just downloaded the package from internet. So it means my private instance is able to connect to the internet, which earlier it was not able to connect. Is it clear, guys? Any question in this? Oh, silence.
I kind of missed the last part of you troubleshooting and connecting to the private instance. But this class is actually recorded, right?
Let me repeat you the last section. Okay. So you were I just woke up from the sleep. Okay. Okay. I understand, guys. It becomes late for you guys, so you might feel sleepy after being tired, and
Leonard, are you serious?
I feel so. Okay, so let me repeat the last section. Okay, so till the point
Okay.
we connected through SSH, right? So we connected through SSH.
Right.
We run the yum update command, and we saw that it was not able to connect to the internet. It was not able to download the package,
Okay.
right?
So we created probably a file and copied the file, the private key part, and save it, and then we connected to the private instance using the private IP address, right?
Yes. So we were on this instance, and this is already in the AWS network, right? And
Yeah.
it is having the permission to connect to this because of the main root table root. So in one VPC, one instance can communicate to another instance until and unless there is a stopping privilege. So just we were on this instance and we tried to connect to this one, and we successfully connected to this through SSH. Once we connected on this, then we run the yum update command, and after running that yum update command, we saw that this instance was not able to download the package. Fine.
Okay.
Then what I did, after doing all the configurations of the NAT, I went to the root table, main root table, because anyways, there should be some root for this instance, private instance, to communicate to the internet. So, and this instance or this subnet, private subnet, is associated to the main root table. So, what I did, I went to the main root table, and in main root table, I have added one root.
IP. Oh, okay.
So in this
One
root,
destination.
in this route, you just need to use 0000, the one which we use for the private public IP address. And here you need to select the NAT instance, not the internet gateway.
Okay.
After let me remove this and let me add it one more time for you. So o.o.o.o/o, and here I will not use this one. I will use NAT instance because this
Okay.
instance or this private subnet will communicate to the NAT instance, not to the internet gateway. What will happen if I select this one? Both the subnet will become public. So there is no use of keeping one private. So make sure that you are selecting this NAT instance and then save it. And once you do that, you will be able to connect to the internet. Just let me show you one more time. If I type yum install httpt -y, it got started downloading. Okay? It means this instance is having the connectivity to the internet. Clear? Okay, so I am just uploading this recording on the Google Drive. Please go through this and practice this NAT instance at your home. Okay.
Yeah. Hey guys, can we work together on this?
Leonard will say no, not now.
Leonard, Chris, and Congo. Webster.
I hear you.
Boy, I'm more check sense now. Maybe if we do this in just create some sessions, so work together on this stuff.
It is very, very important.
Leonard, you can get lost.
I mean, it's very important. We do so that I mean, we just take some project.
Yeah, because it's in an online meeting. This is if you go for that side, go create an online meeting, then we'll try to work together.
Oh yeah.
Hey Kumar, sorry, we are actually chatting in a different language.
No problem. So I'm just closing this session. Shall I do this?
Excuse me?
Shall I close this session or you want to continue here?
I mean, basically, is the class finished? Are we supposed to do some practicals?
I will be uploading the document and I will also be uploading the video on the YouTube today, just now, and you can practice it.
Okay.
Yeah.
Please do send the documents, on our email and then upload the video. So in case of anything, we can always, check on the recording. So.
Yeah, sure. So I will do that.
Thank you.
Yeah. Thank you. Bye bye. Have a nice good night.
All right. Bye bye. All right. See you tomorrow.